My name is Patrick Lynette. I'm an associate professor in the Department of Civil Engineering. Prior to coming to USC, I was at Texas A&M for about 10 years in the Department of Civil Engineering after I received my graduate degrees from Cornell University. The classes that I teach at USC are the undergraduate fluid mechanics class, which is the fundamental introduction trying to understand how fluids move, how they behave, how to understand fluid flow in pipe systems and pumping systems. So the research that I do at USC, it's investigations into tsunami impacts on the coast, hurricane impacts on the coast, events that are pretty rare and they cause a lot of damage. So fundamentally we look at things like how the waves break, the types of forces that they cause on structures, things like computational fluid mechanics, understanding currents. After these large events, whether they're tsunamis or hurricanes, we go out into the field, usually a week or maybe 2 weeks after the storm has finished, and we go and we try to measure the effects of these events. So we may go and find out how high the water got and what types of damage we saw. So we've done it a number of times for tsunamis. I've been throughout the Pacific many times since 2004. Most recently I was on the Jersey coast after Hurricane Sandy to try to do very similar things. And so this was somewhat personal for me because I grew up in that area and I went back to see the boardwalks and the amusement parks that I remember as a kid more or less destroyed and now floating in the ocean. But hopefully the types of information that we found when we were out there will go back into redesigning, and we'll go back in these communities will rebuild, and they'll rebuild their houses so that these types of things shouldn't happen again. So what we have behind me here is a wave tank. What it is a long channel which we will fill with water, and on one end of the tank behind me we have what we call the wave maker. It's really a moving wall or a moving piston that we can control very precisely, and we can generate a very specific type of wave. When we generate that specific type of wave, we'll put instruments in the tank. We'll better understand how the wave evolves, how it propagates, things like pressures and velocities underneath the wave. And we'll take that information that we get from these experiments and we'll use it to better guide designs in coastal areas where we have to understand loads and forces due to waves on a building. The big issues in civil engineering right now really focus on designing structures, designing infrastructure systems so that they're both sustainable and resilient. So when we think about traditional engineering, you may think about designing a single structure, but what you have to realize is that inside that structure you have systems of different structural components interacting together. And furthermore, all the individual buildings themselves represent components inside a wide system. You have transportation systems, building systems, and all sorts of communication networks. So they all interact, they all couple. And what we have to realize is that in order to build these systems to be sustainable and resilient, we have to understand how they all interact, and we have to incorporate that interaction when we design these structures.